Hi everyone and welcome to the We're Gonna Make It podcast show, your go-to podcast for exploring the fascinating world of emerging tech in digestible bites. I'm your host Harshdeep, and today we're delving deep into the digital realm to an essential part of your computer, the GPU. Now I can sense some of you wondering, why should I even care about a computer component? Well, you will comprehend the GPU and appreciate its significance in our tech-driven economy by the time we're through today. First things first, let's demystify this term GPU. This acronym stands for Graphics Processing Unit, a chip that dictates what you see on your screen, from vibrant graphics on your spreadsheets to the latest blockbuster streaming in stunning 4K. Think of the GPU as the engine in the vehicle, that is the graphics card, powering every visual element of your digital experience. There's a common confusion between the GPU and the graphics card, often used interchangeably. While they're closely related, they're not identical. The graphic card includes the GPU, memory chips, cooling components, connectors, making it a complete package for generating and transferring graphics data to your monitor. Now you might be wondering, as an investor, why should this matter to me? Understanding GPUs can offer a unique perspective on the market dynamics and opportunities today. Initially designed for creating high-quality graphics, GPUs have proven to be powerful tools for many high-performance computing tasks. This prowess has not gone unnoticed by the tech titans in the industry. Leading GPU designers such as Nvidia and AMD have expanded their horizons, exploiting GPU capabilities beyond graphics to a broader range of heavy-duty computing applications. Here's where it gets interesting. These applications are not just powered by your average consumer-grade graphic cards, but by specialized computing products equipped with potent GPUs and plenty of memory. No display output here, just sheer computing muscle. In this avatar, GPUs have become pivotal in several booming technology sectors, from gaming and virtual reality to artificial intelligence and crypto mining. Let's talk about AI, a field where GPUs are particularly critical today. Unlike the CPU, which is the more familiar brain of the computer, is adept at doing few tasks simultaneously, GPUs are designed for simultaneous multitasking. This makes them ideal for training AI models that need to churn through massive amounts of data at a rapid pace. This knowledge about GPUs can be a game changer for investors, so they can focus on companies that design and manufacture GPUs, such as Nvidia, AMD, but also pay attention to those utilizing GPUs to power their tech. These could be AI startups, gaming companies, or even cryptocurrency platforms. And speaking of crypto, GPU-based mining is less prevalent today with the rise of specialized mining chips and changes in the Ethereum's platform. However, we've still got altcoins like Ethereum Classic, Ravencoin, Monero, Zcash, which all still rely on GPUs for mining. While not as robust as Bitcoin or Ethereum, these alternatives hold significance in the cryptoverse, contributing to an intriguing chapter in the GPU history. Now, knowing about GPUs also equips us to understand and predict market events better. For instance, a global chip shortage could directly impact GPU manufacturers, triggering a potential price hike. This effect would ripple through the industries reliant on GPUs, altering the tech landscape altogether. And to illustrate real-world applications and the importance of GPUs, let's consider artificial intelligence, specifically OpenAI's large language models like GPT-3 or the more recent GPT-4. These AI systems, trained on extensive database of the internet text, power applications like ChatGPT. But how does this connect to GPUs, you ask? Well, training these colossal AI models involves crunching through mind-boggling amounts of data, a task where GPUs shine with their ability to perform thousands of calculations simultaneously. We also have GPU manufacturers like Nvidia and AMD, which are critical enablers in the space. Nvidia's A100, V100, and H100 Tensor Core GPUs and AMD's Radeon Instinct accelerators testify to the vital role in advancing AI and machine learning today. It's important to remember that deployment of these powerful GPUs isn't hidden away in remote server farms. They are right here in our everyday applications like ChatGPT, where we interact with AI models in real time on a daily basis. This underscores how central GPUs are to the current and the future tech developments impacting businesses and consumers alike. Now, imagine a future where our everyday devices become even more intelligent, where AI powers everything from our morning alarms to late night TV binging. It's easier to think about this world by picturing the essential building blocks of this technology, the microchips. So far, you've heard about GPUs being the superstars of this show. They're at the heart of our powerful gaming rigs, and they're the reason why Nvidia's stocks have been hitting all-time highs. GPUs have been great at handling AI tasks, primarily because AI in simplest terms involves running lots and lots of fundamental math problems all at once. Picture a massive army of tiny workers, each doing a small bit of work, but making huge strides together. That's what a GPU does. It has many small cores, each performing simple calculations, allowing it to handle complex AI tasks. But as they say, change is the only constant, and as we delve further into the world of AI, we are noticing shifts on the horizon. Firstly, GPUs are becoming pricier. And secondly, the demand for AI is evolving. As AI continues to evolve and permeate various industries today, we've started to see AI chip market diversify into three main segments. First is training, the second is cloud inference, and the third is edge inference. Training refers to teaching AI models to understand data and making decisions, a segment currently dominated by a major player called Nvidia. However, cloud inference and edge inference, which used trained AI models to make predictions or decisions, are increasing day to day. As more and more companies use AI in their operations, the demand for inference, especially cloud-based ones, is set to skyrocket. But there's a catch here. Running inference tasks on GPU can be expensive and resource intensive. Moreover, companies integrating AI with other functions like search or social media, tasks that currently work best with CPUs, may explore alternatives to GPUs for their workloads. We're also starting to see trends towards edge inference. This is where AI operations are performed directly on your daily devices, such as smartphones, laptops, you can name it. And these devices are more likely to use CPUs or mobile SoCs rather than GPUs itself. Big players like AMD, Apple are already heading in this direction, adding AI functionality to their CPUs and mobile processors. But here's the twist in our story. Enters a character from the shadows called the FPGA, or Field Programmable Gate Arrays. It's a less famous technology than GPUs and CPUs, but it could be a game changer. FPGAs are like transformers. They can be reprogrammed after production to do different tasks. You may not have heard about FPGAs today, as they are typically used in lower volume applications like industrial or aerospace systems. But as AI models keep changing, the adaptability of FPGAs could make them an attractive option for AI inference needs. So what's our takeaway from this? While GPUs will continue to be heavy lifters for high volume, high profile AI models, we should monitor the growth of CPUs, mobile SoCs, and even FPGAs in the AI semiconductor landscape. The future of AI might not be as monolithic as it seems. It might be a diverse ecosystem of different chips working together to create the AI-powered world we all envision. Well folks, there you have it. Today's deep dive in the intriguing world of AI and semiconductors has shown us that while the spotlight may be currently on GPUs, the cast of players in this saga is much broader and more diverse. Our tech landscape is continuously evolving, and it's an exciting time to be a part of this journey. Remember, progress is born out of change. As the AI landscape shifts, the rise of alternative technologies like focus on CPUs, mobile SoCs, and even FPGAs opens up new possibilities for innovation and growth. These chips have unique strengths that make them suitable for different AI applications. Together, they represent a dynamic and adaptive ecosystem that has the potential to bring us closer to a more innovative, efficient, and more connected world. So, as we sign off from this episode, let's embrace the changing technology landscape with keen interest. After all, these tiny chips are leading us into the future filled with unimaginable possibilities where AI permeates every aspect of our life, making it better, easier, and more enriched. I hope this conversation has enlightened and spurred some curiosity about AI and semiconductors. We will continue to dive deeper into these topics and many others to unravel the intriguing complexities of our technological world. Thank you for joining us today on WGMI. It's always been a pleasure. And this is me reminding you to stay curious, keep exploring, and remember, no matter how complex the tech landscape seems, together we are going to make it. Goodbye.